All right, imagine this. You walk into a massive library and books are scattered everywhere. Some are on the floor, some on the wrong shelves, and some don't even have labels. Now you need to find a book on business intelligence. But with this mess, good luck. Now picture the same library but properly organized. Books arranged by subject, labeled neatly, and sorted alphabetically. You walk in, check the catalog, and find your book in seconds. That's the difference between random, unstructured data and a well-organized data warehouse. And that's exactly what we're talking about today, how businesses organize their massive amounts of data so they can actually use it. So welcome back to SmartSlides. If you're new here, hit that subscribe button because we make AI, data science, and machine learning super simple. Today, we're diving into dimensional modeling, which is a fancy way of saying, how do we store and structure data so businesses can actually make sense of it? By the end of this video, you'll understand what is data modeling and why do we even need it? What is dimensional modeling and how does it work? What are fact tables and dimension tables? Why businesses rely on this to make big decisions? Even if you've never touched a database before, I promise this will make sense by the end. So let's get started. All right, let's start with the basics. What is data modeling? Imagine you own a small coffee shop. Every day, customers come in, order coffee, and you write down their names, what they ordered, and how much they paid. At first, this is easy. You just jot it down in a notebook. Now, fast forward a year. Your little shop has grown into a chain with hundreds of customers daily. You now have multiple locations, online orders, discounts, loyalty programs, and suddenly your little notebook system doesn't work anymore. Why? Because you have too much data and no structure. This is where data modeling comes in. Instead of keeping a messy notebook, you organize your data properly. Customers go into a customer list, transactions go into a sales log, and product details go into a product list. Now, whenever you need to check something, you don't waste time flipping through pages. You have a system that works. It's simple. Without structure, data is useless. Data modeling prevents missing or duplicated records, makes it easy to find information, speeds up decision-making, helps businesses grow without getting lost in their own data. So in short, data modeling equals organizing data like a pro. Now, before we go deeper, here's something cool. Data modeling happens in 3 stages, just like planning a house. Stage 1, conceptual model. This is like drawing a rough sketch of your house. No details yet, just an idea of where things go. Stage 2, logical model. Now we start adding details, like the size of the rooms, number of floors, and layout. Stage 3, physical model. Finally, we build the actual house. This is when we create tables, databases, and relationships. In simple terms, conceptual model equals rough idea, logical models, detailed plan, physical model equals the final product. All right, let's talk about dimensional modeling, a concept that makes data analysis easier, faster, and more meaningful for businesses. Imagine you're running an online store. Every day, customers buy products and their transactions get recorded in a database. Now, at the end of the month, the CEO comes in and asks, how much money did we make last month? Which product sold the most? Which city had the highest revenue? If your data is just a huge pile of raw transactions, answering these questions is going to be painful. You'd have to manually dig through thousands, maybe even millions of sales records, figure out which products belong to which categories, and then somehow put everything together into a meaningful report. Sounds like a nightmare, right? That's exactly why businesses use dimensional modeling. Instead of keeping data in a random, unstructured mess, it organizes everything into a structure that makes analysis fast and simple. With dimensional modeling, all your business data is categorized and stored in a way that lets you quickly generate reports, dashboards, and insights. This is critical because businesses rely on data-driven decisions to stay competitive. Without dimensional modeling, even a simple sales report could take hours or days to compile. But with it, you can get answers instantly. Now, let's get into the core idea of dimensional modeling, fact tables and dimension tables. To put it simply, fact tables store the numbers. Dimension tables store the details that explain those numbers. Let's break that down with an example. Imagine a scenario you own a clothing store. Every day, you sell t-shirts, jeans, and jackets, and you want to track your sales. So fact table is where you store the actual sales data, numbers that change every day. It includes things like how many t-shirts were sold, how much total revenue was made, how many customers made a purchase. Think of it like a spreadsheet that tracks all the sales happening in your store. But just knowing we sold 1,000 items isn't enough. We also need to know who bought them, what they bought, where they bought it, and when they bought it. That's where dimension tables come in. Dimension tables store the descriptive information about each sale. For example, let's say someone buys a t-shirt from your store. That sale might be linked to customer dimension, who bought it, name, age, location, etc. Product dimension, what product was sold, t-shirt, size, color, brand, etc. Date dimension, when was it sold, year, month, day, time, etc. Store dimension, where was it sold, branch name, city, region, etc. Each dimension table gives context to the numbers in the fact table. So instead of just saying we made $10,000 in sales, you can now analyze which products generated the most revenue, which cities had the highest sales, which age group buys the most. And the best part? You can filter, group, and analyze this data however you like, instantly. This is why businesses use dimensional modeling. Without it, they'd be stuck manually crunching numbers from raw transaction logs. Now, let's take this one step further. Sometimes, data needs to be grouped into levels to make analysis even more powerful. This is called a hierarchy. For an example, sales by date. Let's say your boss asks, can you show me sales trends over time? If your data is structured properly, you can break it down like this: year, quarter, month, week, day. Now, instead of just seeing the total sales number, you can compare sales year over year, analyze sales month by month, zoom in to see daily trends. This allows businesses to spot patterns, like seasonal trends, slow months, or peak shopping times. Another example is product hierarchy. Now, let's say your boss asks, which category of products sells the best? Your data can be structured like this: category, brand, product. So instead of just seeing total sales numbers, you can compare sales by category, like electronics versus clothing, drill down into specific brands like Apple versus Samsung, see which exact product sells the most, like iPhone versus MacBook. Hierarchies help businesses analyze data from different angles, starting from a broad view and then zooming into specific details. And just like that, instead of digging through millions of rows of data, businesses can instantly answer questions and make smart decisions. And that's it. That's the power of dimensional modeling in action. We started with why raw data is useless unless structured properly. We learned how fact tables store numbers and dimension tables store details. We saw how hierarchies help businesses zoom in and out of data for better analysis. All of this saves time, speeds up decision-making, and helps businesses grow. Now, imagine this on a massive scale. Banks, hospitals, e-commerce stores, social media companies. All of them rely on dimensional modeling to turn data into valuable insights. If this video helped you understand dimensional modeling, hit that like button. Comment below if you have any questions, and subscribe for more easy-to-understand AI and data science content. Next up, we'll be diving deeper into advanced data warehousing concepts, so don't miss it. Thanks for watching, and see you in the next one.